Okay, we're back doing kinematics, and what do they have for us this time? Time it takes for a car to accelerate uniformly from rest. From rest is code for you weren't moving at first. To a speed of 28.9. So initially we were at 0, we end up at 28.9 meters per second over a distance of 12.5 meters. Okay, they want a time for this. The obvious and wrong thing to use is, I'll do this in red because it's not good, time equals distance over velocity. This only works if you're at the same velocity all the time, and that's not the case here, or if you have an average velocity, which we do not. The velocity is 0, and then it's 1, and then it's 2, and then it's 3, and it keeps rising until it gets to 28.9, so neither of these can be used as the v in this formula. We need something a little deeper. If we could find an acceleration, we could use Vf equals Vi plus At, and that would do it. Our initial is 0, our final is 28.9. If we knew A, we could get a time. We don't have the acceleration at the moment, but we can get it because this formula, which is a champ, it's been helping with a lot of these problems, can do it for us again. 28.9 squared, 0 squared, 2 times an A we don't know, times they told us the displacement is 12.5 meters. So let's see what we can get from there. 28.9 squared equals 0 squared plus 2 times, I don't know what A is. This is horizontal motion, so it's not 9.81. That's only for things that are falling, moving vertically. And that's not what race cars normally do. And our displacement is 12.5. So, calculator comes out. 28.9 squared is 835.21. Equals 0 plus 2 times 12.5 is 25. And if we want A alone, we divide both sides by 25. So 835.21 divided by 25 gets us 33.4. I'll carry an extra. 33.41 meters per second squared is the pretty impressive acceleration for this car. Now that we have that, this formula can help to get us the time. We could do V final is 28.9, V initial is 0, plus acceleration we now know is 33.41, we just found it, times t. The 0 doesn't matter, so if we're trying to solve for t, we want to divide both sides by 33.41, and we get t equals 28.9 divided by 33.41, 0.865 seconds. Wow, that ain't no normal car. I was thinking about another way to do this one, but actually I don't believe it's going to work. The other thing I considered was doing distance equals VIT plus 1/2 AT squared. But here again, we know the distance is 12.5. VI is 0, so that whole term just goes away. The trouble is, again, we don't have the acceleration. So we would still have had to do this step to get A. And then we could have done 12.5 equals 1/2 times 33.41 t squared. And if we solve that for t, it should give us the same result. But I don't think it's any, I think it's a little bit more work actually than what we did here. Now, this is a numeric response, and let's look at how they want us to do this because it's kind of an odd request. They basically say they want the answer in scientific notation. So we had 0.865. If we turn that into scientific, we would move this decimal one step to the right, and that would give us 8.65 times 10 to the minus, we only moved one step, so it's times 10 to the minus 1 seconds. And then they're saying the three digits of our mantissa are the A, B, and C, and the power here is our D. So if we were answering this, that 8 would be our A, the 6 would be our B, the 5 would be our C, and this minus 1 would be our D, so we'd give our answer as 8651. Kind of odd formatting, but they do that sometimes with numeric responses. It's good to get used to that. Cliff diver. Oh wait, there's a clear, sorry. That's better. Okay, if a cliff diver stands 18 meters above water, okay, so if you jump down 18 meters, you start out with no velocity. When you first step off a ledge, you're not moving up or down, and then you pick up velocity as you fall. You'll have a final velocity just before you hit whatever this surface is, and that's what they're asking us for. Now, directions are important here, and we'll get to that in just a second. I think best formula for this is... Isn't this thing good? It just keeps being exactly the right thing over and over again. We're looking for final velocity. Initial is 0. Acceleration is 9.81 because we're on Earth, presumably. That's where most cliff divers are. And our displacement is given as 18 meters. Now, in a lot of questions, we've been saying that G is minus 9.81 because it's oriented down, and that's fine. And we can use that here. But in this case, the displacement is also down, so we should be giving our D as minus 18 meters, because they're both in the same direction. If you want, because the direction convention is up to you, you could also say, I'm just going to say that down is positive for this problem, and then I'll say my acceleration is positive 9.81, and I'll say my distance is positive 18.0 meters. Either one can work. What you must not do is put minus 9.81 for A, like out of habit, and then just put 18 for the D because they didn't mention a negative sign here. If you do that, you will get a flaky answer that you will not like. So, I'm going to go with down being negative because I'm kind of used to that. So, in my version, that's going to be minus 9.81, and this displacement is going to be minus 18. Those negatives will cancel here, and it won't end up being a big deal. Vf squared equals, Vi is 0, I'm just going to leave it out. 2 times A is 9.81 down, displacement is 18, also down. 2 times 9.81 times 18 gives 353.16. And if we want Vf by itself, right now Vf is squared, and if you want to unsquare something, you square root it. From that we get Vf equals 18.8 meters per second. Now technically, even this, when you're solving a number squared equals a value, you can get a positive or a negative answer, and strictly speaking, this should also be downward. And it should have a negative sign on it because the velocity is falling down. However, even the answers didn't bother to include that negative sign, so I guess they're okay saying that because they said speed, which means a scalar quantity, one that doesn't have a sign on it. So our velocity is minus 18.8. If you're just talking speed, you're allowed to ignore the negative sign and just say 18.8. Fair enough. What else have they got for us? We have ground level. An arrow starts out down here, Goes up for a while, tops out, falls back down. And they say it takes 6.72 seconds to get back to the ground. And they want to know how high was it up here. D equals question mark. We know our velocity is 0 up there. That's the point where the arrow has stopped rising and is just about to begin falling. And they never do give us an initial velocity, so we're kind of out of luck on that. We don't know our final velocity here, so bit of a problem. There are a couple of ways to approach this one, and they all kind of rely on the fact that this trajectory here is symmetric. If you start at ground level and go up to the apex and then back down, the amounts of time that those things take are identical. So if you take 6.72 seconds and divide it by 2, you find that you spend 3.36 seconds rising and then another 3.36 seconds falling. And that's helpful. That tells us the time is exactly 3.36 when we get to the top here. And from that, we can get if we use VF equals VI plus AT, our final velocity is 0. We don't know our initial velocity, but we know our A should be minus 9.81, and we know the time, if we're right at the top, is 3.36 seconds. We can get our initial velocity from there, and that would be kind of helpful. I don't know if it's essential, but I kind of want to find it, and if you think you see another way to do this problem, you're probably right, but this is the first path that I found, so I'm going to follow it. So, final velocity, if we're talking about just getting to the top here, is 0. Equals an initial velocity I don't know. G is 9.81 and it's negative, and the time is 3.36 seconds. 9.81 times 36. Sorry, 3.36, geez. 9.81 times 3.36. So we get 0 equals VI minus 32.9616. Take this to the other side, and we get VI is okay, so that's our initial velocity. Now that we have it, can we find how high we got here? Yeah. There's at least one way to do that. We could say distance equals VIT plus 1/2 AT squared. Or, you know what? This would work too. We've been using this over and over. We could say that if we're at the top, our final velocity is 0. Our initial is 32.9616. Our acceleration is minus 9.81, and from that we could find D. But as good as this is, I've been using it over and over in these solutions, so let's just prove we can do things another way. I will run through this one using VIT plus 1/2 AT squared. Our displacement is going to be VI is 32.9616. Our elapsed time there is 3.36 seconds plus 1/2 A is minus 9.81, and then we get 3.36, and don't forget to square it. So now we mash the calculator a lot, and we get 32.9616 times 3.36, 110.75 meters, and then we get 1/2 times 9.81 negative times 3.36 squared, 55.38, 110.75 minus 55.38, it's going to be like 55.37. 55.37 meters should be our maximum height. I feel like that was a little bit more work than the VF squared formula, but I just wanted to do something different because most of these questions there really is more than one way to get them solved. So 55.37 meters. This given only had 3 digits to it, so really our answer should only have 3, and it should be 55.4. There it is.